Okay, this is problem number 10 from our text. It's a question that's asking you to maximize the profit if you know that the cost function is this, and then the price function or the demand function is the equation below it. All right, so the basic concept here is that we know that our maximum profit is going to come from taking the entire revenue and then subtracting the entire cost, and then maximizing that. We're going to find the absolute maximum of this profit by taking the derivative and setting it equal to 0 of that equation. All right? So we've got the cost function, that's pretty straightforward, but we're going to take this demand function and transform it into the revenue function by simply multiplying by x. This is the price that we can expect to get for each of our widgets that we're manufacturing. So if I multiply by the total number of those widgets, which is just x, that'll give me the revenue I'll get. So R of x then is nothing more than 1700x minus 7x squared. Okay? So now, to maximize this, I'm just going to take the derivative of this, and I'll get R prime. That's the marginal revenue. And then the cost function will be our marginal cost when I take the derivative of that. But if I'm going to set this equal to 0, how do I solve for this? Well, you can see that if I just move the marginal cost over, I get R prime of x is going to be equal to C prime of x. All right? So what does that mean? Well, if I take the derivative of this, I will get 1700 minus 14x. That's R prime right there. Marginal revenue. Well, that's going to be equal to the derivative of this. Constant goes to 0. This is then 500 minus, when I bring the 2 out front, 3.2x. When I bring the 3 out, it becomes plus 0.012x squared. Okay? So I just need to solve this. All right? How do I solve that? Well, identify the problem type. It's a second-degree polynomial. So we know that we solve second-degree polynomials by shoving everything over to one side. 0 then is going to be equal to 0.012x squared. Then if I move 14 over, 14x, add that to both sides, plus 10.8x. And then when I subtract 1700, it is minus 1200. And I've now got my quadratic like that. So I can put that into the quadratic formula. And let me see if I've got that. Nope, but you've got A. Well, actually, you know what we can do is we can divide. No, we got A is equal to 0.0212. B is equal to 10.8, and C is equal to negative 1200. Actually, I think that when we do put this into the quadratic formula, we get x is equal to 100. I think it works out to be x is equal to 100. So that will give us a maximum profit as long as our second derivative of this indicates that the second derivative of our revenue function is less than the second derivative of our cost function. That will tell us that it's a moment of concavity, so the point we found is at a maximum. So if I take a second derivative of this, I get negative 14. Is that less than the second derivative of this, which is minus 3.2 plus, and then 0.024x? Okay, so x has got to be positive, and so negative 14 is going to be less than negative 3.2. So this is a period of, an interval of concave down, so that is our maximum value right there, okay?